Thank you, Adrien. Thank you, all the speakers, and welcome everybody to this second SIMBA Power Electronics conference. Let's get started with our keynote. So the SIMBA team and myself have a lot of things to show you today. Let's get started. So we have three main things that we would like to announce today. The first one is SIMBA Online and SIMBA Cloud. The second thing is the release of SIMBA 25.11. And finally, we want to introduce you to the future of SIMBA. So let's start with SIMBA Online and SIMBA Cloud. And here is Guillaume to tell you all about it.
Yeah. So thank you, Emmanuel, for this introduction. So I'm going to share my screen. Emmanuel, I sent you a request for this. Yeah, that's great. Sorry. Here we are. So can you see my screen?
Yes.
Yes, great. So yeah, my name is Guillaume. So I'm from SIMBA, and I'm also an associate professor in the engineering school of electrical engineering in Toulouse, in the south of France. So to quickly show you the awesome potential of SIMBA Online and SIMBA Cloud, let me tell you the story of a professor, for example, in power electronics. Let's call her Ellen. So Helen likes showing concrete elements to her students during her courses, and that's why she uses a simulation software such as SIMBA, so that she can show some fairly good stuff to her students during her courses. So till today, for most of teachers, the story ends here. But now things have changed, and there is SIMBA. Indeed, Ellen is able to upload her simulation file to SIMBA Cloud, where she will be able to manage the access of these simulation files. So to share this with her students or anyone who's got the link, so that all these people will be able to see the simulation file on SIMBA Online, will be able to simulate it and to get some pretty results. Okay, so let me show you this in three steps. First, how I built the simulation file with the desktop application, then how to upload it in the SIMBA Cloud, and then how we can see it in SIMBA Online. So so here is the SIMBA file we have created in SIMBA, in the desktop application. So this is a simple model of a work converter with two outputs, two windings here. And we also have here a transformer model in the magnetic field. So here are some classical results with the MOSFET voltage, here the influence of the leakage, the flux inside the transformer, and the output current of the first winding. So now I'm going to upload this to SIMBA Cloud. So this is the SIMBA website. So here I'm logging, and I'm going to go to SIMBA Cloud. So here I'm going to upload the file I've just prepared. Yes, and so by default, the access to this file is private, and I'm going to change this. Okay, so now I'm able to share this with my students, and that's why, okay, I choose the public anyone with the link. Okay, and so now I'm able to share it. I'm going to copy the link, and I'm going to change the browser in order to prove you that's perfectly works. So here I'm with Microsoft Edge. You can see that I'm not logged in, and I'm going to paste this address, and you can see that SIMBA Online is loading the simulator. So you can recognize here the model of the fork converter we have just considered. Let's simulate it. Of course, it's always as fast as in the desktop application. Let's get some results. for example, the MOSFET voltage, we are full screen, and yes, so that with this, the students are able to see their own simulation results. And for example, if they want to study the influence of some elements, they can do some modifications. For example, let's change here the leakage inductor, simulate it once again, and you can see here that okay, the overshoot voltage of the MOS voltage has decreased. So yeah, that's all. So to sum up in 3 points, here we have got 3 features. First, the desktop application, which allows you to build a beautiful design, to prepare all your simulation file, then upload it in SIMBA Cloud, which allows you to manage and share the file, and then the SIMBA Online, which will allow all the users who've got the link to simulate and get results of SIMBA, of the simulation file with SIMBA, even if they don't have a SIMBA license, because it's a free online view. Yeah. Yep. Thank you, Emmanuel.
Thank you. Thanks a lot, Guillaume. Yes. So now we are going to introduce SIMBA 25.11, and that we are going to release today in preview and in a few weeks, and the final release will be available in about 2 weeks. So to tell you more about it, here is Jérôme.
Thank you, Emmanuel. So now let me give you a quick overview of the other updates coming with 25.11 release. So first, we've added new useful models to SIMBA. So these include an operational amplifier working entirely in the power domain, and also a new PWM block offering various modulation strategies such as SPWM, DPWM, space vector modulation, or third harmonic injection. We've also introduced a new SPICE speed channel MOSFET, so based on datasheet parameters, and it's coming with several control devices such as a ROM source and also a new logic comparators. We also completely redesigned our PID controller in this release to add new features. So now you have the possibility to activate saturation. You have also 2 anti-wind-up strategies. So you have also 2 anti-wind-up strategies regarding the saturation, a low-pass filter on the derivative term for stability, of course. And also we added a discrete version of this PID for the domain control. In addition, our PID API, our Python API has been updated with new functions. So for example, you can now export images of your designs via Python, so for documentation or reporting. And also this release includes a new circuit builder API in the Python. This circuit builder allows you to automatically build circuits from a list of devices and constraints. So you define the device and the constraint of your design, and the circuit builder will automatically place the device respecting classic building rules. And of course, the 25.11 release also includes numerous bug fixes and performance optimization across the GUI, the solver, and the SPICE models. So now Ryoko will give you an overview on a new magnetic device. So Ryoko, please.
Thank you, Jérôme. The final feature introduced in version 25.11 is a non-linear magnetic core model, enabling you to simulate magnetic saturation using user-defined nonlinear VH data. accurately capturing magnetic saturation is essential for advanced power electronic simulation. Even if the input current is sinusoidal, like the center image here, the core saturation can distort the magnetic flux, leading to the harmonics in the devices. With SIMBA 25.11, the software calculates and replicates these effects, providing you with more comprehensive simulation insights. So we are glad to release this version.
Thank you, Jérôme and Ryoko, for your presentation and for your nice work on SIMBA 2511. So it's available today. You can go on your website and directly download it. It's available as a preview. And it will be, we just make sure that everything is fine. And we will release the final version on November 20, 2 weeks from now. And SIMBA 2511 is actually the last version of SIMBA as we know it. Because today we are going to introduce something extremely new. So, and we would like to discuss about the future of SIMBA. So if we look at all the releases of SIMBA that we made since day one, so SIMBA is now 4 or 5 years old, we put all our effort on making SIMBA as powerful as possible, as fast and as accurate as possible. And SIMBA now has one of the best simulation solver for power electronics on the market. SIMBA has everything the power electronics engineer can dream of. It supports C code. It has one of the best solver on the market. It is multi-physics, including magnetic, mechanical, thermal. It's compatible with SPICE. We have the AC sweep, the steady state detection, and a lot of extremely advanced features. But when we listen to our users, we can see that there is still a pain. And the pain in SIMBA today is not really on how powerful it is or how fast it is. The pain is really about the experience of using the tool and the experience of using the interface. So we have decided about a year ago, a year and a half ago, to rewrite entirely from scratch the graphical user interface of SIMBA. And so we put a lot of effort in making SIMBA fast, powerful, and accurate, but now it's time to make it effortless. So what is our vision? What is our pole star for this new version of SIMBA? So first and foremost, we want to deliver an exceptional user experience. We want people to fall in love really with our software. We want to address all the issues, the shortcomings of the current interface. That includes the charts, that includes the Python, that includes the overall stability of SIMBA. We want to be cross-platform from day one, so the new interface works on Windows, Linux, and macOS. And finally, we want this new interface to be the foundation of SIMBA for the next 10 years, which is probably a good lifetime for a user interface. So let me show you what it looks like. And there we go. So here is the new graphical user interface. We have here the main design in the middle. So the first thing you can see, it doesn't look like the current one, right? It looks way more modern. We have a tab-based navigation. So we can create new tabs. We can put tabs on the side if we want to. We can, on the left-hand side here, we have a navigation tool to explore everything that you need. So the design, the libraries, the results, the thermal data, the SPICE model, and the scripts. And because in SIMBA, the new user interface, you can now write, run, and debug Python scripts. So directly I can open a Python script and I can run it from here, and you can see that it's actually run this Python script. We've also rewritten entirely the charts, the charts engine from scratch. So we can look at we can put the tabs, we can put them on the side. We can put different waveforms. We have now charts property. to have different subplots. So really, we put the user at the center and we want to deliver the best experience possible. So for instance, I can take my chart, and if I want to make it floating to put it on another screen, it's possible as well. So we also have a beautiful dark theme if you are into that. And we have a centralized search engine where you can search around all your libraries, your designs, your charts, your results directly from a unified interface. So the goal of this interface, again, is to have the best experience possible with SIMBA and with Python. So what's new in this interface? It's multi-platform. It's super fast. We have a completely new chart engine. We have tab-based navigation with optional floating window for multi-screen, and we have Python embedded into SIMBA. But there is one more thing. It's not only the new user interface. We have also developed what we call a SIMBA assistant, and that will be included in SIMBA, the new interface from day one. So what is the SIMBA assistant? It's a chat engine, a little bit like ChatGPT if you want, that can automatically generate or edit SIMBA Python scripts from natural language input. And it's extremely powerful. So let me show you quickly how it works. So now we have this tab assistant. We can create a new session. And from this new session, we can actually ask it to generate scripts. So let's say, for instance, build three-phase power inverter, 100 kilowatts, 800 volts DC, and 300 volt AC, 200 hertz outputs, something like this. Okay, and I can run it. It will take about a minute. Now it's syncing, and it will build a model from scratch. What is very nice about it, it's not actually setting the parameters of existing model. It's actually building a completely new model from scratch. And we can ask it to modify it as well. So it's really like a companion that will help you to create new circuits, edit circuits. And it's extremely powerful. So this LLM knows power electronics, of course, and control theory, but also it knows our Python API. And the goal of this is to lower the barrier for new users for Python and accelerate also the workflow for experts. It can be used for many things. You can build any topology from scratch. You can create any type of parametric analysis, including optimization, with a few lines of prompt. And it can also convert drawings, screenshots, or even netlist into a working SIMBA model. So the SIMBA assistant will be available as an add-on in 2603. The privacy is extremely important to us. So only the prompt is sent to us. Everything else in your design is not shared with us, and the data is not trained to share any models. As a matter of fact, we don't, even if we want to, we don't have access to your prompt and to the data you decide to share. You can also decide to host the LLM on-premise using open source model on your on your own architecture. So if you decide to go that way, you will not share any data outside of your organization. And so that's first, this is new. We are the only one to have this feature, and we're really excited about it. I think it will help the current and the new user to understand the power of SIMBA and the scripting directly. So what will be the roadmap for this release? So first, we have a private beta of 2603 at the end of this month. So everybody that wants to try it, just let us know, and we will send a link to start playing with it. We'll have a public beta in January. So everybody that wants to try it will be able to try it. And finally, the release will be in March. That's why it's called 2603. And we are really, really excited about this release.